Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer B, congratulations. If you'd like to hear my explanation of how I found the answer, please continue watching. So, monochromatic light with a photon energy of 4.1 times 10 to the minus 19 joules is incident on a metal surface. The maximum speed of the photoelectrons released is 4.2 times 10 to the 5 meters per second. So I'm going to initially think, what equation am I going to use to solve this question? And that's going to be the work function equation. H is the Planck constant, F is the frequency of light, and that's equal to the work function, which is the minimum energy to release an electron from the surface of a metal, plus the maximum kinetic energy that any emitted electron can have. HF is that those two numbers combined together give the energy of the photon. So that HF is actually going to be equal to this value here. Well, the first thing I need to do is find this kinetic energy of this photoelectron. So let's do the calculation up here, and I'm going to use the good old-fashioned kinetic energy equation that you've been using for years now. The mass of the electron is 9.11 times 10 to the minus 31 kilograms. The speed we're given in the question, 4.2 times 10 to the 5 meters per second, and don't forget to square that. And that gives an answer of 8.0 times 10 to the minus 20 joules. And I'll be able to use that number for EK max in this equation. So I'm just going to rearrange this equation because we're trying to find the work function, phi, which is going to be equal to the energy of the photon, HF, minus the maximum kinetic energy. So I can put the numbers in there. As I said, HF is the photon energy, 4.1 times 10 to the minus 19 joules, minus the maximum kinetic energy, 8.0 times 10 to the minus 20 joules. And if I put those numbers into my calculator, I'm going to get an answer of 3.3 times 10 to the minus 19 joules. Answer B. I hope you found this useful. If you did, please press the like button. All comments will be welcome, and I hope you'll share this video and watch more in the series.